Life revolves around the things that we see, the things that we touch, the things we hear, the things we consume, and even things that we feel. But things don't necessarily come in good terms all the time. Humanity is faced with a lot of challenges, and some of these challenges cannot be fixed with basic solutions. And sometimes, it is analytical chemistry that can help our society.
Some of us may not know, but analytical chemistry is actually used to solve our day-to-day problems. Analytical chemistry is the study of chemical analysis through the use of chemical instruments. It helps determine, identify, measure, and quantify different substances present in a sample. So, how does analytical chemistry help solve a societal issue?
Given the impact of heavy metals that greatly affect the environment and human health, analyzing the different compounds present in these substances can contribute to coming up with a solution against that toxicity. Heavy metals are known to have a high density and atomic weight, and most of these are found present in the Earth's biosphere. Even though some of them are vital for humans like copper and zinc, some heavy metals also contribute to a number of undesirable repercussions on the environment, like converting mercury to methylmercury, which creates sediments of toxicity.
Heavy metals naturally occur in the environment and are vital for us to survive. However, too much accumulation of these can become hazardous and affect our health. Examples of heavy metals that contaminate the environment are mercury, cadmium, arsenic, chromium, nickel, copper, and lead. And if we are not careful and aware of these, we may be led to serious problems that can lead generations and generations to suffer.
So, in order to save us the risk, analytical chemistry techniques would be of great help to reduce potential risks. A technique that could help with heavy metal toxicity would be Atomic Absorption Spectroscopy, or the AAS. The AAS relies on the atomization of determining the flame sources to form free atoms which can absorb radiation at discrete elements. The wavelengths would each correspond to only one element and with an absorption line in picometers to give an elemental selectivity. The amount of energy that would be absorbed is proportional to the concentration of a determinant that is present in the sample, such that of the Beer-Lambert law.
AAS is an inexpensive instrumentation that can detect 62 different metals in a solution, and it is very sensitive that it can measure ppb or parts per billion of a gram in a sample. So going back to detecting heavy metals, AAS can be used in the analysis of metals like arsenic and mercury, and it can be used to separate and pre-concentrate analytes from samples by a reaction that converts them into hydride vapors. A common reagent for reduction is sodium borohydride, which is also known to be used in paper making and dye industries.
For this technique, the Beer-Lambert law applies wherein absorption equals to the products of extinction coefficient, path length, and concentration. The components to be used would be a hollow cathode lamp, an atomizer, nebulizer, monochromator, and a detector. Because AAS makes use of wavelengths of light absorbed by an element, metal ions and metalloids in an aqueous sample can be vaporized and atomized by a flame and therefore can thoroughly analyze the heavy metals that are present in the environment.